Alright, so concavity just deals with how the slope by itself is curved. So the graph of concave up kind of looks like a little tiny happy parabola, while the graph of concave down kind of looks like a sad parabola. We can use the second derivative to determine the concavity of a function. So the fancy definition of concavity is letting y equals f of x be differentiable on the interval of I. The graph of f of x is concave up on I if f prime is increasing on I, and concave down on I if f prime is decreasing on I. So if the first derivative is increasing, then the second derivative has to be, well, if it's increasing, that means that the derivative will be, well, positive. And likewise, if the first derivative is decreasing, the second derivative has to be negative. Alright, so this uses the definition of concavity to determine whether the function is concave up or concave down. We can use the following test. So what the heck is this concavity test? That says that the graph is twice differentiable function of y equals f of x is concave up on any interval where y double primed is greater than 0, and concave down on any interval where y double primed is less than 0. Basically, the concavity test can be summed up by the following pictures, and while it's kind of humorous, it might be helpful to remember concavity, please understand that this is never, ever, 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 ever a justification on any of the tests. Okay, so what this says is that, okay, if I've got f double primed is positive, then you're going to have concave up, which is just going to be f. And if f double primed is negative, then we're going to have f being sad. Honestly, the way that I remembered this as well as this happy face and the sad face, is I also saw the up kind of looks like a happy little U. And then down would just be DOWN, would be that concave down, is the other way that I remembered that, because, well, if smiley faces and sad faces aren't enough for you, why not? Alright, but everybody's got their personal preference. I've never seen my way used any other time, but I have seen the little happy faces and sad faces used actually quite a bit. Alright, so let's go on to example 5. Alright, so using the same graph from the first example, we need to indicate which portions of the graph are concave up and which portions are concave down, and we need to label the point in which the graph changes concavity. So I see that this upper portion definitely looks like it's concave down the whole time. Alright, and then I notice that my other portion looks like it's going to be concave up, and then that means at some point in between here, I'm going to have to change from being concave down to being concave up. Alright, and so as I get closer and closer and closer to the middle, which is where that should happen, I see that, hey, it should probably happen. Oh, geez. About here. Funny how that works. And if you notice, that's also an important point on our derivative graph, which we graphed earlier. Okay, so on the first derivative, it's just going to be, okay, I was green and green and green until up here, which means that I was concave down until there, and that just tells me my slope was negative. Then on the other side of that point, it was blue, which means that I was concave up. Remember that concavity deals with that second derivative, so it just really cares about where is my second derivative going to be positive or negative, which is why on that first derivative graph, I can basically just look at my slopes and call it a day, which is kind of nice. So it does say sketch the graph of f double prime on the same grid. So if this is f prime and this is f of x, alright, that means that f double prime of x is going to have a slope of 0 here, which means that I should have a x-intercept on f double primed, which I'm going to be drawing in purple. And then from here, I had a negative slope from negative infinity until then. Alright, and then I had a positive slope after that. Wow, I cannot draw whatsoever today. But that's about it. So if you notice where my second derivative is above my x-axis, that would be where my original graph was concave up. It's where we were bluing all the way back up here. And then where my derivative is, my second derivative, is below the x-axis, that is where my original graph was concave down all the way back up here on f of x. Alright, so this is going to take some practice. It's going to take some getting used to, because I know we've talked about drawing graphs of the first derivative, but maybe not so much the second derivative. So it says that we need to sketch the graph of f double primed on the same grid, which we did. Okay, cool. And then we also need to notice that concavity of f changes when f double primed changes signs.